Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Ben Wilson.
Hello there.
Francois Bertrand.
Howdy.
And Charles Max Wood from devchat.tv. And this week it's just us. So we thought we'd talk about what you should know if you're getting into machine learning.
When I went freelance, I was still only a few years into my development career. My first contract, I was paid $60 an hour. Due to feedback from my friends, I raised it to $120 an hour on the next contract. And due to the podcasts I was involved in and the screencasts I had made in the past, I started getting calls from people I'd never even heard of who wanted me to do development work for them because I had done that kind of work or talked about or demonstrated that kind of work in the videos and podcasts that I was making. Within a year, I was able to more than double my freelancing rates, and I had more work than I could handle. If you're thinking about freelancing or have a profitable but not busy or fulfilling freelance practice, let me show you how to do it in my Dev Heroes Accelerator. Dev Heroes aren't just people who devs admire, they're also people who deliver for clients who know, like, and trust them. Let me help you double your income and fill your slowdowns. You can learn more at devheroesaccelerator.com.
I know that most of our audiences for most of the shows is about 50-50, new or newish. And then the other half are usually, they've been working in the field for a couple of years all the way up to whatever. And so, I thought it'd be interesting just to kind of talk through, okay, let's say you're making a career switch into machine learning, or you're just starting to dabble with it to see what it's all about. You're starting to take it seriously, right? What are kind of the skills, the essential knowledge that you have to get in and to be able to contribute? And I'm not really sure where to start. I mean, I just kind of fiddled with some of the tools myself. So
yeah, it's a broad question and it's a broad topic. There's so much to know and learn about this field. And it's one of those rare professions that it doesn't matter how much time you spend, you will never have enough time in your lifetime to learn it all. It's such a massive ecosystem to understand. Mm-hmm. And it's daunting. And that's why I usually give advice to people is figure out a specialty that you want to devote specialization to. Figure out some area of ML, whether it's, or pure data science work, where it's, hey, I am really interested in Bayesian methodologies. Get familiar with all the fundamental tools of everything else of how to solve problems, linear regression, ensemble methods, get familiar with deep learning. But if you're going to specialize in something like Bayesian modeling, really get a true understanding of that particular isolated field. Read the literature on it. Some of those books that cover those concepts were written long before computers were around. So read them, understand them. And I'd say the other important thing for really getting started in this field is to have a solid understanding of 3 core competencies to be successful as a data scientist or machine learning engineer. The first one is statistics and math. You have to know how these things work, why they work the way they do, and what data that you're creating to pass into a model or a solution that you're crafting by hand, how that's going to actually affect the results of the project that you're trying to do. The second thing to think about once you learn all the algorithms and that you're going to be using and get your foundation is, how do I write good code? And writing good code is not just writing something super over-engineered and crazy fancy. It's, how do I write something that, even without any comments in my code, can I look at that code 6 months later, understand how it works, troubleshoot it without a lot of extra work going into it? And is it something that I could send to my peers and they'll instantly be able to understand how it works and be able to maintain it without spending too much time? So that's the good coding standards, testable code, stuff like that. And the third aspect for success in data science and ML work is something that a lot of people never really talk about, which is soft skills. Know how to talk to humans. You never want to be the skunkworks data science team who sits off in a corner somewhere. You want to know how to talk to people, how to talk to subject matter experts in your business. Those are your internal customers. You gotta get in good with them, because they're the ones that are going to help inform your project success or failure. They're the ones providing you feedback, telling you Are you going down the right path? Are you solving the problem? And really, they're the ones that are going to be your champions for getting that project used by humans or used by systems. Those are like my three big things that I tell people, and things that I wish that I knew when I got started.
Mm-hmm. How about you, Francois? Do you have anything to add or agree with or jump on there?
No, I mean, as you know, my background is in graphics. I'm tangentially involved with the field. I do consulting on data visualization, and I do agree that kind of if you're going to work with people to be able to understand their needs, they may not know what they want themselves, or if the more you know what your field, what your work entails, you can help work with them, help them even figure out what they want, what would work best for them. So you need to be empathetic to their needs and what they're really trying to get at. And so being able to talk to them and have good communication is definitely important. Very much agree.
Oh, that's another point. The visualization. That's a really critical key skill, I think, for data scientists to have, is to be able to know how to craft a story with visualization and being able to distill something super complex that isn't in the language of data science, but is in the layperson's language of a business unit, I think is super critical.
Yep. That's actually most of what I do is really, we want to show the client this data, make it visual, right? Make it just, you look at a graph or at a presentation, you can immediately understand the underlying problems or solution or state of the data. Definitely.
Yep, absolutely. It's interesting too, because I'm going to back up on a couple of these and probably ask some follow-up questions on some of it, Ben, on your points, and then on to Francois' point as well with the visualization. But I tell people all the time, I'm like, look, you need skills, and you need basically three types of skills. You need your technical skills, right? And we're kind of talk through that. You need your people skills, right? To be able to work well with people and communicate well with people. And then you're going to need, usually at some point, some kind of leadership, mentorship, other skills that don't necessarily fall in line with I can work well with people or communicate well with people. Some of those skills are the same, but your ability to take the lead on a project and then push it through, push it along, make it happen, a lot of times is invaluable to companies, and they'll reward you for having it. But yeah, just I want to rewind real quick to picking, and we'll just take them in order, right? So picking a specialty. I mean, how do you figure out what specialty you should be picking?
It depends on who's paying your paycheck, is usually how I tell this to people. Learn a tech. The first specialization that you get, and this isn't just one thing that you have to learn in your career. You can specialize in multiple things, but the first one that you go down, and whether this be technical platform that you're running your code on, language that you're implementing things in, or field of data science that you're specializing in, that first triad of things that you have to learn in order to be successful to implement something, it's going to be daunting to learn. It's all a long, hard slog to get all of that knowledge and experience. But what guides you in that is what problems you're trying to solve. What company do you work for? What issues are they having? What did they hire you for? And that's usually what people's first specialization ends up being. There's no guarantee that you're going to work somewhere long enough to fully master that specialization. And you may move over to a different company and they use a completely different tech stack. They have different problems that use different algorithms to solve them. But learning further in different specializations will help to make it a little bit faster, all the subsequent ones, and you'll just learn all that stuff quicker. But that generally informs what type of company you're going to want to look for, what position. And what I mention to a lot of people when they're doing job hunting, or they're like, hey, have you heard of this company? They have a data science position open. Do you think I should apply? I'm like, yes, send me over their job description. And if it's completely vague, there's nothing in there about what problems they're trying to solve, I usually tell them like, hey, talk to that hiring manager and say, what are you going to be paying me to do? And if they don't know, that's a red flag. They're just like, hey, we heard we need data science. We need data scientists. You are our data scientist. Run away. That's scary unless you're really experienced and you want that ambiguity. But when you're getting started, you should have a good, solid understanding of what sorts of problems you're solving, what tech you'll need to use to solve those, as well as which family of algorithms and approaches and methodologies you'll be employing to solve those problems. So that early on in your time at that company, you can buy all the literature, you can read it, you can test stuff out, you can play around and learn it before you have to lay your cards down on the table with a project that hopefully actually works.
That makes a lot of sense. What if you're just kind of a hobbyist like me, right? Where I don't really have a company that's paying me to do it.
Oh, then play jazz. Figure out a problem that really excites you and just learn it. Try it.
I was wondering, is there anything that helps you stand out as you're learning or being a hobbyist, or get some cred to your skills, like the Kaggle competitions, or just some projects or places where you can, if you're just sitting around, okay, I need to do something with data science. Like, are there starting points or things you can apply this burgeoning knowledge to as you learn and experiment?
Oh yeah, definitely. Join a data science community. There's a couple of really great ones. Most of them are Slack focused, where relatively experienced people who come from a statistics or engineering background that are now called data scientists. And we've been doing this for like a decade or more. We're in these communities and there's a lot of new people that come into them. Sometimes it's people that are just like, hey, I just want to learn this. My core job is this other thing. Sometimes we have pure back-end software developers that are in there. Their day-to-day job is writing C++ or C# or Scala or Java. And they're like, hey, I just want to learn ML. They can ask us questions and depending on how cool they are and how nice they are, sometimes we'll give them homework. I have a number of people that I do that with. And they're like, hey, I want to be pushed to learn this stuff. And I'll be like, all right, go download this data set from this government organization. Figure out how to get that onto a VM, create a Docker container for me that has an ML stack that you can use. And I want you to predict what the risk of forest fires are in California for the 2021 fire season. Go do that for me. You have 3 months and you can ask me up to 4 hours worth of questions during a week. And it's amazing when presented with an actual problem and the pressure of somebody saying, hey, I want you to do this for me. You'll learn it.
That's great. Yeah, that's exactly what I was wondering about. Yeah, ways to get started with some external motivation always helps.
Mm-hmm.
Yeah, we do similar processes at the company I work at now, at Databricks in the field. We have mentorship programs that are very similar to that, particularly with the AI data science work, where people that might not come from an ML background, they want to learn this stuff. They've read books, they've looked at blog posts, they've checked out Kaggle, seen what other people have been doing. But it's a lot different when it's you having to actually solve a problem that somebody else is telling you to solve. But then you also have that mentor as a crutch when you get stuck. And you will get stuck.
Mm-hmm.
Even experienced people get stuck all the time. That's like part of what we do. But having somebody to bounce ideas off of and say, hey, I'm seeing this weird thing in this multi-collinearity that exists in the feature set. Like, what do I do with that? And then the mentor might just use the Socratic method with you and say, well, what do you think is the problem here? Having you think through how to analyze and get that repetitive thought process working in your head to be skeptical of data and then know how to handle it.
That's cool. I tell people to find coach too. So
yep.
I love it. Now, you did mention a couple of technologies that were kind of baseline things like deep learning. And there were like 3 of them that you said you specialize, but you do need to know these kinds of things. Like what were those things?
I mean, at its core, you need to know a tech stack, like a framework to execute. I'm not here to push an agenda. Like, the company I work for has a pretty great tech stack for ML and AI. A lot of people use it, but there's so many other ones out there.
Mm-hmm.
If you're dealing with a small data size problem, Docker container running on a VM that's doing an Anaconda stack, or if you just want to roll your own Python sklearn, that's great. Learn that tech stack, learn the nuances of it. If you're doing extremely large scale ML tasks where your training set might be terabytes of data, you're on Apache Spark at that point. You're using Spark ML. If you come from a research background from a university, you've been working 5-6 years in post-grad work, you're probably really familiar with R. Use RStudio. You just need to get familiar with a place to do ML. And then the next aspect that goes along with that tech stack is a language. So I'd say the vast majority of ML these days is done in Python. And when I mention to learn Python, that means learn a bunch of different aspects of it. Blogs and demos, even on READMEs of GitHub repositories for the open source packages, they're imperative or declarative style. So it's scripting. It's not production code. You need to learn how to write production code as a data scientist, or particularly as an ML engineer. So learn basics of object-oriented programming. Learn how to create a class. Learn what abstraction is, encapsulation. Learn concurrency. You want to make your job cheaper or faster to run? Learn how threading works. Implement it. Learn functional programming. There's a lot of stuff in data science that applies to functional paradigms. So those are the core key things to learn. And then the third aspect of being successful is learning how the algorithm works. If you're specializing in ensemble methods, you better know how entropy calculations occur for node split decisions. How does that thing actually do what it does to create that model? What is that model? And understand the theory behind it. Because if you're just blindly using algorithms without understanding what they're actually doing, it can get incredibly challenging to figure out how to make that better or diagnose when something goes wrong.
Makes sense. We've done shows and shows and shows and shows on how to write good code on the other channels. So yeah, and then the math. How do you learn the math? I mean, is that included in some of these tutorials, or is that just kind of hand waved over by some of these tools, and so you have to go learn it somewhere else? Or yeah,
I mean, the foundations for it, typically in a university program, I've actually met people that are self-taught. Like they taught themselves linear algebra. It's like, cool. You bought some textbooks, you went through it and learned how all that stuff works. Statistics is super heavy used, not so much in every ML implementation with the algorithm focus, but if you're doing feature engineering work and doing exploratory data analysis, that's all statistics. And you should become very familiar with stuff like, what is a distribution function? How do I create a CDF or an EDF? And what do these things actually mean? Should I scale my data? Am I expecting a particular distribution on my features and my target if I'm doing supervised learning? How do I select the correct type of model based on the shape of my data? If I have a logarithmic distribution on a regression problem, should I use some form of a GLM that's going to handle that appropriately? The answer is yes, but it's one of those, you don't know what you don't know. So if you don't know statistics and then you're trying to get into playing with applications of ML, it becomes very confusing very fast. So having that foundation, reading some books on statistics, getting some later year like bachelor degree textbooks on statistics and going through them, and you don't have to do all the homework, but like going through and understanding these concepts. And there's also great books on ML that explain algorithms and explain the statistics aspect. Read through them and get familiar with it.
Have you heard of any online sources or courses that were particularly relevant or good, or is that nothing in particular? Just do your research.
Call me a Luddite or old school. I really like printed books. So that's how I learn best. I learn best by reading and also listening to people talk. But if I'm gonna learn a really complex topic, I like to just see it in front of me. I'll actually get a paper and pen and I'll write down equations and solve them and try to understand it that way. It's just how I learn. So I don't do a lot of those courses because I don't know. I'm old school.
Fair enough.
Yep.
They do exist though. I know a lot of people that have taken them and have learned a lot of stuff. It's just different learning styles for different people.
Yeah, I graduated from college 15 years ago. So I took those classes like I took the linear algebra class and the statistics class. The linear algebra class I took twice because I failed it the first time. But,
yeah. Amen, brother.
I mean, to be fair,
not the only one, huh?
That stuff is not simple.
No, but yeah. That's definitely interesting. But it makes sense to the degree that if you understand what's going on under the covers, then if you have something that fits the model or fits the pattern mostly, but not completely, and you understand the underlying features, then you can adjust it and confidently know that you're going to get something back that's at least closer to what you expect or closer to what you want.
Yeah, what you said about, for example, understanding the decision trees and the splitting points and things like that. I can remember some projects where that was kind of a key component, and just applying the default algorithm or just as is, wasn't quite getting there, and being able to dig in and understand that was really, really valuable.
Yeah, and most applications of ML algorithms that are out there in any of these toolkits, sklearn or in R packages, if you're paying your way to data science work using SAS, there's hyperparameters that you need to tune. Those defaults are just placeholders a lot of the time. Sometimes they're good placeholders. A lot of times they're not going to give a good result for your application. You need to know how to tune them, what they are, what they're actually that process that's calculating, and going through and knowing how those algorithms are implemented and how they work sets you up for data science work later in your career, which is when you're experienced and you've been doing this for 8, 10, 12, 15 years, you're going to get to a point where there's no out of the box implementation that's going to solve a problem. And you need to either implement somebody's white paper that is solving this problem, but nobody else has implemented it yet, or you need to write one yourself that solves the problem. I don't recommend doing that early on in a career. That is a recipe for disaster because there's nuances of how to implement it, not just from a mathematics perspective, but more from a software development perspective. But when you get down that path, understanding how all of this stuff works is super critical, and being able to read how other people have done it from these open source packages.
Looking forward, actually, and this anyone predicting the future is a bit at risk. It's a bit sketchy, but is there anything you can see as being on the way out and on the way, conversely, something on the way in, or something that some general trends as far as you really shouldn't be getting into Fortran, for example, or getting languages or procedures that are fading away or fading in?
Funny that you mentioned Fortran. A lot of people don't know that a lot of the mathematics computation programs that are out there that power the underlying tech of these ML packages are still written in Fortran because it's so ludicrously fast for computation.
Nice!
BLAS operators, the stuff that is below the kernel level that's actually operating on the hardware, a lot of that is Fortran code. Some of it was written in the late 70s, and it's still, people are still using it today. They don't even know that they're using it, which I always find amusing. But trends that are going away in data science, if I'm going to put on a Sears hat for a second, bad code is going away. It has to. There's going to be a schism in the data science community of people moving away from I'm going to create a script that is poorly developed, but mathematically sound and good, and punting that over the wall to a software developer and saying, hey, can you implement this for real in production? The schism is going to happen of separating those people who refuse to learn how to develop proper code and the people that are building models, but also learning how to put it into production themselves. Tooling is going to get better, of course, with ML ops, making the path and the road to production simpler, which it should be because it's mostly repeatable work. But you're still going to have to learn how to write code. If you're in data science work, it's not that you're going to be unemployable 5 years from now, but you're not going to be commanding the same level of responsibility or sweet gigs at sweet companies that you would if you had sort of that full stack data science where you can do the algorithm, you understand how the algorithm works, and you can solve a problem, but you can build your own visualizations that don't look like garbage. You can communicate that process, and you can go soup to nuts, pushing something into production.
It's interesting too, because you're talking about these skill sets that people ignore. And for a long time, you brought up the kind of the soft skills, communication skills. For a long time, a lot of developers ignored those skills, right? And you mentioned that again, where you need to be able to communicate. And what's funny to me is that, like I have a brother, he just finishing his degree in computer science. I have a cousin that dropped out of his computer science program in college and kind of went to work full time.
And they both asked me at different points, what's the most important skill that you can have as a developer? And I told them, look, beyond just being able to write code, you need to be able to communicate with other people, because you don't write software by yourself anymore. It just isn't done. And so those soft skills are critical, right? And I think it's interesting, you're tying this into programming skills and some of these other skills that I think people are they wave their hands at, right? The math skills too, right? Where a lot of people just get in, they kind of hook up the algorithm, and maybe they learn to tweak it from somebody else, and then they just kind of get in and hope for the best. And it doesn't matter if it's pretty, it doesn't matter if it's, if they understand what's going on under the covers, they'll just sit there and kind of stab in the dark until they get what they want. And you're saying that you're not going to be able to get away with that going forward.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
No, because the reason that people get away with that right now is companies aren't aware of the true cost of hiring people that don't know what they're doing or that are excessively experienced.
That's true everywhere.
Yeah. But when they tune up and they say, okay, so if we hire some inexperienced software developers, we'll know within 2 months of a couple of sprints that they're not building something that actually works. And we need to kind of take a step back and say, all right, maybe we need somebody with a little bit more experience here to lead this team and mentor them. With data science, if the company's unaware, if it's their first couple of projects, that could be 14, 16, 18 months of sunk cost where you're paying a team of 6 or 8 or 10 people who are sitting in some skunkworks room trying to nerd it out and just throwing stuff at the wall, trying to make it work. If you don't have somebody there to guide those people and help them grow and learn and mature and communicate with the rest of the business and understand all those soft skills that we're talking about, when they find out that that's what's been going on, that there's nothing useful that's come out, or the product of all that work is completely unusable garbage. I've seen it personally at companies. The entire team just gets fired. We're dissolving the data science team. And the company gets that. They can actually get to a point where they're like, we don't need data science. We tried it. It doesn't work. It's a waste of time. It's like, no, you just set a bunch of people up for failure because you didn't have the right mentorship in place. You didn't have somebody guiding this team down the right path.
And from the engineer's point of view, I guess you're emphasizing those soft skills in that, and pretty much trying to align the work with the needs of the company and the project, and paying attention that you're not just going off on a tangent or executing work that is not going in the right direction. Sometimes you get specs that actually won't, in the end, fix the problem they're trying to solve. So I guess you're saying those soft skills are really making sure that your work is valuable to the company in the end result. And keeping all the stakeholders, to use a buzzword, involved enough so that the work doesn't go to waste. Yeah, I'm just trying to put concrete terms on what those soft skills are and what they entail. Yeah.
And it's also setting ego aside for data science members, where I think we get it into our heads early on in careers that the more sophisticated the algorithm that we're using, or the thing that's hot right now, is the best way to solve something. So I'll see a team on their first project.
That's not unique to ML either.
But it's dangerous to ML because it's expensive. So somebody's like, oh, we want to forecast our revenue over the next, for a year in the future. That in and of itself is kind of crazy. And it's really hard to do that. But somebody will be like, oh, I read a blog post about using an LSTM to do this. So I'm going to use Keras and TensorFlow, and I'm going to build this super complex system to do this. And it might work pretty well. It's going to take a while to build that correctly and get it working, but it's really complex. And that might have been their assumption when talking to the business, that that's what they wanted. But if they had just talked to finance and said, hey, how are you doing this right now? Can I just see what you're doing? And they might get a discussion with them and saying that, oh, there's all of these exogenous features that are going into this that are based on what we would call tribal knowledge. Like the finance knows that there's these actions being taken by the business, and there's all this information that they're putting into their manual, revenue forecast or sales forecast. And what would have potentially solved the problem a little bit better is something that is pretty old, something like a Ceramax model, where you have an old statistical method whose basis is from the 19th century or actually before that. Code is relatively simple, and it can train and produce a result in seconds instead of having to train a deep learning model and build all of the infrastructure to support that. So the big thing that I notice when having frank conversations with business stakeholders is it generally drives more simple implementations, which are less costly, faster to implement, and most importantly, they're easier to maintain.
Yep.
Yeah.
And that's the big win for data science is these things don't stay static. A model, when it's in production, that's the beginning of its life. You constantly have to change it, add features, monitor it, check for drift, because everything is going to fall apart if you don't do that. I mean, it falls apart anyway. Those are controls to fix it once it falls apart. And if it's super complex, you're in for a lot of work.
Yeah. I mean, in my consulting, that's something that's probably my main driving principle is to see on each project how does the work add value, right? And what you said on the visualization front, I have a pretty crazy VR visualization system for data sets. And sometimes people ping me regarding that, and then we'll talk about it. And I'm like, you know what? The best thing you could ever have is this 2D, like off-the-shelf graphing solution on a website, right? Not a crazy literally 20 times more expensive VR visualization. And it's really, and they're like, oh, it's not as cool, but it solves the problem so much better. And I assume that's what you're referring to at every level, basically.
Yeah, definitely. And on the topic of visualization, I've seen some interesting things that people have tried to do with not only overly complex plots, but I've been brought in to talk to customers before that are trying to craft a visualization, and somebody just had it in their head like, I don't want to use Matplotlib or Seaborn in Python to do this visualization. And they start rocking out some D3JS and generating all of this code for rendering. And you just sort of ask like, okay, this took you 2 weeks to create this plot. I mean, it's a really beautiful plot. It's super sweet. It's animated. When you hover over it, you can collapse things and it'll re-render. And like, yeah, I agree. This is awesome. But why did you build this? Like, well, I wanted to make a really fancy presentation. Like, why? You're trying to tell a story with this. You're not trying to put it on a website and have people be like, whoa, this is really cool. So with data science work, yeah, it's very tempting to do something fancy just because it's cool. And that's really down to mentoring and experience. Somebody being a part of that team who can say, you know what? Yeah, that's cool. Please do that on your own time if you want to learn that. But we need to solve this problem and make a visualization that who can understand the story you're trying to tell instantly.
Yep, absolutely. Francois, do you have stuff to add as far as like data visualization and just keeping it simple? Because for me, usually I'm looking at a graph or something, and I'm just looking for like one or two pieces of information, right? Is it going up and to the right like I want it to, or is it not, right? Or how are we doing compared to whatever other time frame, right? The bells and whistles are nice, right?
Yeah, ideally you'd get there. Sorry for interrupting, but yeah, it really figuring out what is that simple visualization that will get you that information. When you're dealing with a ton of variables and you're trying to narrow it down to, that's almost the end goal, right? Sometimes it's upstream work to see how do we structure the data and how it's processed and what kind of analysis do we run. So we have a linear graph. To the left is good, to the right is bad, or vice versa, or whatever. That's pretty key. And that's where the soft skills of digging into what the problem is, who are, what are the decisions being made? Because at the end of the day, you're trying to inform decisions, or at least provide information so decisions get made. So it's really the key thing is, what are we trying to answer, to solve, to display, and seeing what is the best medium to do that. So we do get to that, the simplest possible visualization.
I've got a fun question for you, Francois. Sankey diagrams, where you're trying to display, let's say, 50 classes of aggregated data. You ever seen people do that? And what are your thoughts on those?
I have know not. What you asked.
I'm with Charles on that one.
What was that?
Sankey diagram. What?
It's the ribbon plots where everything starts in one big group on the left, and then all these arrows branch out to show the interrelationships between the data that you're trying to display. I see so many people using visualizations like that to convey to the business, and that it's just like, what are you doing? Like, what? This is so complex that the only human on the planet that can understand what you have generated is you.
I'm not even sure that's true. I think sometimes that person doesn't even know.
Yes.
There is no shortage of useless diagrams out there. And sometimes I think it's a bit of surrendering. There's like, we got to visualize this data, here it is, but it doesn't mean it's helpful, but we couldn't reduce it enough. And that's I guess the art of visualization. Sometimes, you're trying to visualize 10 things at once, and there's only 3 dimensions in the world we perceive. So you gotta take slices, have multiple slices next to each other, try to boil down the extra dimensions. But it's the best diagrams are probably the simplest and easiest to read. And if they're not, then that's a problem. And sometimes things are inherently impossible to visualize if there's just too much data. But it's about making the right choices so the visuals are useful. That's my pet peeve. Just visualizations that don't tell you anything, or that are just so confusing that they're not useful. There's a couple of graphs like that you're like, okay, that I get what you're telling me, but it's not intuitive enough that I can look at each data point and kind of figure it out. But in aggregate, I can't deduce anything from it. And it could give you an idea of the general state of the problem. It can tell you how bad the problem is. Like, here's the problem. This is what we're trying to see. But sometimes it's good to ask yourself, is this helpful at all? Or should I just not put a diagram up or do something different?
So one thing that you've both kind of talked about with this, and I think this is something that we've all kind of been talking our way around, is then, you're saying if you're going to put together diagrams, know what people want to know, right? If you're going to build a model, what question are you trying to answer? And so all of this comes back to talking to whoever cares about what answer you're trying to get to, or what data you're going to show, or what information they need to have at their fingertips, and then putting together the right thing, correct? So how do you have those conversations? Like, what does that look like? Because sometimes it's as simple as, what do you want? And they just say, well, I need to know this very simple thing. And sometimes you have data or structures. We did an episode on bioinformatics yesterday on Adventures in DevOps, right? And it's like, some of this stuff gets really wacky, complicated. And so, how do you have those conversations with people where it's either subject matter you're not familiar with, or maybe it's a little more complicated than just, is it going up and to the right, or it distributes in this way, to understand what they want?
I mean, I always recommend the Einstein approach, which goes back to the quote that he has of, if you ask me to solve something in an hour, I'm going to spend whatever it was, 55 minutes asking questions about what you want me to solve and what the nature of the problem is. And then I'll spend 5 minutes solving it. ML is not any different than that approach. The most successful project that you can have is the one where you're not just sitting in a meeting and saying, okay, what do you want me to build? Or what's the metric that you want me to optimize for this problem? It's, hey, after this meeting, like, thanks for the presentation that we understand the high level goals of this. Is it okay if I sit down with people on your team for a week and watch what they do? Because the vast majority of ML use cases that businesses are paying people to solve, somebody's already doing it. They might not be doing it the same way that an algorithm would do it, definitely not, but somebody's solving that problem. Unless you're in a completely greenfield space where, and those are high risk ML actions anyway, but if you're in that position where a solution doesn't exist, it's a new thing for the business, ask 59 minutes of questions on that to make sure that you're really understanding what they want. But if it's something that somebody's already doing, sit down with them. Ask them what they do. How do you solve this? Can you show me? Can I just sit back and watch you work and bother you with questions while you're working? Hopefully you buy them lunch every day because you're probably annoying the hell out of them. But
well, actually, to that point, because you mentioned it, it's I think we've been kind of beating into a pulp the argument of soft skills and communication, but I think it can't be overstated. At some point, once your skill set with the tools is so that you can kind of conjure up whatever the problem needs, I think it's really, like you said, 90% of the problem is to really come up with a plan on paper or to know what you're going to do. And that involves talking to people. And oftentimes people will just want to just make this happen, go away, and then, or, do your work. But the work is talking and annoying everyone on the team. And I need a 2-hour meeting. We need to go to what you're doing every day so I can know how to help you. But then it's something that you need to kind of push, at least in my experience, to get me, sit the people down. Maybe I should buy them lunch. That's a good trick. But getting that communication, because once you can plan out, there's only so much you can do. In visualization, you can probably do a bit more, plan what the end result is, because there isn't a whole lot of variability versus maybe modeling. You may not know what's going to work best, but at least in visualization, coming up with, okay, so here's what your job is, here's what you need to know, and or to visualize what would help you, and getting those discussions is sometimes an effort because you need to involve a lot of people on the other side. But it's really important, because at the end of the day, if you know how the tools work, just doing the programming is not that long, compared to the process. But the process is where you can get a huge bang for the buck. The time you spend in the process is going to help so much reduce wasted work or increasing the quality of the results.
Yep, couldn't agree more. And one thing that I find with interfacing with non-technical business experts, and there's a couple of points that I notice. First off, they're usually pretty excited. They're not excited at first. They're usually kind of intimidated to be talking to a nerd about some nerd stuff. But once you break it down and say, like, hey, here's what we're trying to do, and let me show you some stuff now that I've watched you for a couple of hours, and just mock up some stuff that kind of automates some part of something that they find annoying, it sparks this interest in most people. The vast majority of people I've ever interacted with, they get super excited. They want to help. They want to be part of that process. And if you include them into that, use them as your rubber duck effectively. And rubber duck in both ways. Like, you're showing them that they're not maybe going to have any response for how good your code is. Definitely not. But they're going to be able to tell you how good your results are. And they could just get excited about it. But they'll ask questions that are questions that you won't hear from your peers. A data scientist is probably not going to ask, like, hey, well, how does that actually work? And you having to process that in your mind can potentially open you up to realizing that, oh, geez, I might be going down the wrong path here. So that's one aspect of rubber duck. And the other one is having to explain something in non-data science, non-math, non-statistics, non-engineering terms makes you really understand that, and makes you have to go through the process of vetting internally in your head that you're doing the right thing. So it's so invaluable to go down that path.
All right. Well, I think we covered just about everything we kind of brought up at the beginning. Is there anything else that we need to hit before we do the picks?
No, I think we're good.
All right. Well, then let's go ahead and do some picks.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming. And I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
Francois, do you want to start us off with picks?
Sure. I'm going with Clockify. I don't know if you're familiar with it. It's a time tracking software, like cloud-based. It's on the website. There's an app for mobile devices. It's a simple, nothing crazy. It's a time tracking when you're doing consulting. I find that I'm using it in other contexts as well for some personal stuff. It's time tracking that does what it says it does. I had some reservations about sometimes the interface doesn't do exactly what I want it to be, and they're being a bit stingy about their free versus paid option. But there is a free option. You can try it out, and it is what you think it is. It tracks your time. You can specify tasks, projects subdivided by tasks. Once you're on a team, that's in a paid plan. You can have multiple people, different access to different projects and things like that. Like I said, I have some minor reservations about it, but it's one of those things that just gets it done. And there's some nice features to it. So if you're looking for something for consulting or tracking time any which way, you can start a timer on a mobile device, stop it on your PC, and vice versa. What happens to me sometimes, I'll start working on something, then I forget to start the timer, but you can always retroactively just hit start and say, oh, I actually started at that time. That I use that all the time. And it tracks things. There's nice reports by different horizons. You can use it for billing. Anyway, it's nice rounded tool. I found I've been using every day for the past couple of months. So check it out.
Awesome. Ben, how about you? Do you have some picks?
I've got one that's for my fellow data science nerds who are doing stuff in production. New open source toolkit that's coming out by a company called Evidently AI. They're open sourcing their entire framework, and it's a model health monitoring system. It's probably one of the slickest and most comprehensive approaches that I've seen. And it's based in a lot of strong statistical analytics methods. So when you're predicting something in either real time or batch prediction, you want to know, hey, is my model actually deteriorating? When is it deteriorating? What sort of level do I need to start worrying about? This tool, and it's just called Evidently AI. It's free to download on GitHub. It's in active development, but definitely check it out. It will save you from having to build that system yourself. And if you've never built one, let me tell you, it is not fun or easy to build one. So might as well use something that somebody's built for you, and you can contribute back to it as well. So check it out.
Cool. I'm going to get on with a few picks. So I finished Psycho Cybernetics, which is a book about kind of visualizing who you want to be and what outcomes you want, and then letting your subconscious mind work through how you do it. I mean, you still have to do the work, but I've been finding it a very powerful tool for just visualizing who I want to be, like what kind of person I want to be and what kinds of things I want to be doing in my life with my career, with devchat.tv and all this stuff. And I'm really, really, really enjoying it. So I'm going to pick that. And then I'm also going to shout out briefly about another productivity hack that I've picked up, which is called Focus Blocks. You can find it at devchat.tv/focus. I may have picked this on another episode. I don't remember. But effectively, the idea is that, so I've read a whole bunch of productivity books, right? And they tell you to schedule time for like time blocks for getting stuff done. The problem is I'd schedule the time blocks and then I wouldn't do it, right? It'd be on my calendar. I'd have accountability to me and only me. And so I just wouldn't show up. And so what this is I'm able to go into their calendar system and schedule my calendar block. And then when I show up, there's a focus guide there. And so they kind of take you through some breathing exercises and stuff, just get you started. And you commit to what you're going to do that hour, right? And then you put your phone away and you work, you have your webcam on, which is kind of an accountability thing. But I mean, it's been enough for me to just be disciplined about getting time in to work on the stuff that I'm doing. And I can't tell you, it's been like this massive hack. I've gotten way more done over the last week than I probably got done the couple of months before that. And yeah, I'm really, really liking it. So if you want to check it out, devchat.tv/focus, that just lets them know that I sent you over there, really. But it's a really, really cool product. It's put together by a friend of mine. When he first tried to explain it to me, I was like, I don't know. And then I tried it and I was like, wow, this is awesome. So yeah, Focus Blocks is my other pick. I have another book that I'm also reading now, but we have another episode tomorrow, so I'm going to save it for that. But yeah, those are my picks. And with that, I guess we'll just go ahead and wrap up. Thanks for coming, guys. This was a really fun conversation.
Yeah, it was. I'll definitely try Focus, by the way. That sounds interesting.
Yeah.
Working from home, sometimes you need a bit of blitzing on some things to get it done. That's interesting.
Yeah, the other thing with that too is like, yeah, I work from home. My kids will come in. And if I'm on a focus block, I'll just pop the Zoom call up because it shows all the other people who are doing their focus blocks. And then I'll be like, I'm in a meeting, get out. Right. And they're like, okay. And then they get out. Right. So yeah, it keeps me interruption free that way too. So anyway, let's go ahead and wrap up. Until next time, folks, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.